So if you are on this channel, ask me this question of how do you go from this, which is a unidirectional composite with fibers appearing on the edges, to something that looks like this, which means that all the fibers have been trimmed off. That's exactly what I want to show you in this video. But I'm going to show you this in two cases. In the first instance, all the fibers are merged so they represent one entity. And in the second instance, all the fibers are actually individual components, in which case we need to go ahead and individually trim off the boundary fibers. That's what we're going to do in this video. Let's sit back and relax as we get started with this modeling. So, like I said, there are two ways that we're going to go about doing this. So I'm going to do the first instance where we have the fibers actually as merged system. So let's look at the first case. So case one, and this is a case that I'm describing as the system is all merged. And basically what that means is that you've got the metric system and also you've got the individual fibers appearing kind of randomly within a domain of interest. So what we want to then do is to kind of bring them all together. So in the end, what we would have would be this. So we get the metrics first, and then we also superimpose the fiber on it. So that's the superimposition of the fiber on the metrics. So clearly what you can see in this instance that some of the fibers are actually appearing on the edges. So let's just note some of these fibers. So you've got this fiber that is here, you've got this other one that is there. Sort of this is here, and then you've got this fiber, you also got these fibers that are on the edges. And so clearly we don't want to have these fibers that are appearing on the edge. And so how do we go about doing this? The principle I'm going to use is something in ABAQUS called extrude cut. So we're going to extrude cut that. And that means in extrude cutting, you need to create a domain through which you cut through. And the nicest way to imagine what's happening here is that basically we're going to have a system that defines the boundary that we want to keep. So basically that's the domain that we want to keep first and foremost. And then we also create a domain that encompasses the edges that we want to extrude cut. And then we'll basically use that bit, cut through the domain, and then in the end everything is cut and we have the solution that we want. So I'm going to go into ABAQUS and demonstrate how we go about doing this. Here we are in ABAQUS and we want to create this representative volume element in 2 dimensions. And I have a Python script that I've already developed, which again is available for you to download within the description section of this video. And basically that's what the Python code looks like. So I'm just going to do Ctrl-A to select all and Ctrl-C to copy. Then I'll go back to ABAQUS and then I'll go to the kernel command and paste it there. So what it will do is basically to create the model and generate the model that we're looking for. So if you look inside the model, okay, so you've got the fibers. Like I said, the fibers are all merged, so it's a single unit, and then that's the polypropylene system. So if we go to the assembly module as well, so you could see the matrix is there and all the fibers are united into as one entity. So if you look in the instances, so again the fibers are one entity. So what we want to do is to merge them, and then we extrude cut to trim up all the boundary fibers. So we're going to use this command. So I'm going to call it my merged RVE, and it's going to be a merging operation based on geometry, and I'm going to suppress the initial instances and return the intersecting boundary so that I can see where to trim off. So then I'll now need to draw a line around them to select everything and click OK. So it's merged them, and as part of that process, it also created a different path like we know for doing this. So now to trim off all these boundary fibers, all we need to do is to click on this extrude cut option. So it activates the sketching module, and then I use the rectangle. And I know that the dimension of the system that I'm working with is 60 by 60. So I could just start from here, click from there, and then go to that point. So this is fine. And then I'll create a bigger system like I already showed in the sketch. We want to have this system so that the region around here will be the region that represents the extrude cutting option. So after that, then you click done. So that's it. It's extrude cut through the system, and we have a component that looks perfectly exactly where we want it. And of course we can then go within here and do a section assignment to select the matrix region, and then assign properties to it, which is polypropylene in this case, and then select everything, press down shift and control, deselect the matrix, leaving the fiber only, and then assign the properties of the fiber in this instance, and then we have a complete system. So this is how you will go about creating a representative element where you extrude cut, but here the fibers are completely merged. All right, for the second case, this is where the fibers are actually separate entities that are not merged. So case 2, so I'm going to call it a not merged system. So this was the kind of system that the student who contacted me about this asked for us to deal with. So again, we'll start with the matrix as usual. Okay, but then this matrix will also have fibers that are individual components that are standing by themselves. So what I'm going to do here is that I'm going to use a fiber. So this is another one fiber, and then maybe we could also have another fiber that is here. We could also have a fiber that is, you know, technically around there, and then maybe we could have another fiber that is there. So I'm just looking at fibers that are on the edges here. So we're going to then combine them. So here we have the matrix, and then we'll bring in the fiber to combine them. All right, so this is the combined format for this system. So I'm just going to color code them just to indicate that there are different fiber systems. So what we see here is the different fiber systems, you know, different entities. So what we're going to then do by way of merging it is that I'm going to look at one possible case. So if we just extract one of the fibers, so let me call it fiber number 1. So this is fiber number 1. Then we have to do the same thing we've done before by first isolating a region within which we're going to keep. So we're going to keep that region exactly as it was. And then we also create a region, a second bit that encompasses everything that we want. And this way, when we extract this, the part that is left in this model will be just this part that is sort of ingrained. So that's the part that we're going to leave in this situation. And so we'll do the same for all the other fiber systems that make up this case. So basically we have to do it up to 4 times, and then we get each of them extrude cut. But the same principle of extrude cutting will apply in all cases. So I'll show you how to do this in ABAQUS. All right, so to show how we can actually do this for systems that are not connected, so the fibers are not connected. So if you look here, what we see here is that, okay, there are different fibers in the corners. So there's a corner fiber, there's fibers on the x-axis, the front axis, the y base, y top, and also in the inside. And when we go into the assembly mode, you can see the different fibers, and all of them, of course, have different colors to indicate that they are actually not connected. We're going to trim off the corner fiber. So let's start off with, let's say, one of the fibers on the X back. So we have to make that extrude cutting on the part module. So if we double click on that, so that's all we see. There's really nothing around it. So what we need to do is a extrude cut option, and based on this, we'll just need to create the boundary to be used, the inside box and the outside box, like I spoke earlier on. So 0, 0 is the origin, and 60, 60 is, so basically you can see the positioning of the fiber in the space, and then we'll just draw a bigger one, so that again the region around here will be what we use to extrude cut that particular fiber, and leaving what we have inside. So cancel procedure, done. And so with that, we now have a system that is extrude cut. So we go into the assembly module to have a look, so you can see, okay, that fiber has been extrude cut. So why not let's try the Y top. So if we again go to the Y top module, click on that, again we'll just click the inside circle of 0, 0, the inside square with a boundary of 60, 60. Okay, so if we look here, okay, so it's positioned properly, and then we'll just draw the square around the outside one and click done. So again, we've trimmed that, and then we can go through the whole process. If we look at the assembly module, again, the top is done. So let's do the corner fibers. So if you look at the corner fibers, again, the same kind of system. We just need to do the inside box of 0, 0 and 60, 60. And then we'll draw the bigger one around it, and that again cuts through. Go back to the assembly mode, you can see that it's done. So we've got 2 more that we need to go through. So X front, so if we do that, we run through the whole system again, 0, 0 and 60, 0, 60, 60. So that's what we get here, and then we'll just draw a bigger one around it, and we're done. And then finally, so if we go back to the assembly module, so we just need a Y at the base. So with the Y at the base, we go through the same process of 0, 0 first and 60, 0 second, and then we can just do a bigger square around it. It doesn't have to be square, it can be any shape, and then we're done. So this way, we have the system all extrude cut like we did before. Everything fits nicely, and more importantly, the matrix is still in its place. So if we go into the assembly module here, so we can see everything is identified. So I could easily suppress the matrix, and all these individual parts remain as they are expected to be. So this is how we can do this, and extrude cut systems where they are all different particles. So you have noticed that what I have done here involves a little bit of manual exercise work that you can do, But however, the whole thing can be automated, and there is a software that I developed to actually do this in an automatic way, and it's called MultiCalGen. So, and I'm going to just show you how to get hold of it. Again, in the link in the description section of this video, you'll find a link that tells you how to get hold of this software. So the software is supposed to run within MATLAB. So if you get into the software, this is sort of what you see. Here is MultiCalGen 2D, which creates the RVE and all the extrude cutting. And then on the top here is the computational options file that is like a control deck to the software. So when you go to the top here, so basically this is the system that we're playing with. So it's got a dimension of 60 by 60, the RVE length and width. The diameter of the inclusion, in this case the fiber, is 15 microns, a volume fraction of 5%, and it's starting with an origin of 0, 0, but we can move the origin around. And then the inclusion name here is glass fiber polypropylene, and then all that. If you want to learn more about this code, please look at this video that explains more about this code. So all I need to do here is to call the software. So again, MultiCalGen. So if I call it, okay, and then I click enter, so what it will do is that it will run through and create the RVE. So this one candidate RVE, in MATLAB, the way it's plotted. So what we're going to do with this is to then recreate this inside ABAQUS. So within the window, you find that there's the files that are created. So there's a window called ABAQUS simulation. So you open this outside of MATLAB, then this is the code that we have here. So all we need to do is to run this code inside ABAQUS, and then we get our result. Okay, so we've got a blank model called model 1 that we're going to use to run. So all I need to do, file, I'll run the script, and then I'll paste the link, and then that's the Python script that is generated by the code, and instantly we have the system that we wanted. So it's already been extrude cut, and everything is in their individual ways. And this is sort of how you can do the same thing that I've described in this video automatically. So what I've shown here is for a 2D system. However, you may also be interested in doing this for a 3D system. If that's what you want, then this video will be the right video for you. Thank you, and I'll see you in the next video. Bye-bye.